Hello, in this video I'm going to go over resistors in parallel. I have example 1 right here and example 2 right here. Okay, this is number 1. We have a current coming in, which is I. It then reaches a junction, which I explained in a previous video, and it takes two paths. I2 goes one way, I1 goes one way, and the other way. R1 is equal to 2 ohms, R2 is equal to 3 ohms. We're trying to find the change in potential. And we know I, which is 5 amps. So what we have to do is find our EQ, multiply it by the current, which is equal to the potential. Now we have current 1 and current 2 right here, but that isn't necessary. If we find the equivalent R, and basically we can then rewrite the circuit like this. This will be the change of potential, which we do not know. And then this will be the REQ. And then we have this current going around. We then don't have to worry about the split. So the way that we solve this problem is we know that 1 over REQ is equal to 1 over R1 plus 1 over R2. And it would go on as many numbers as we have. And this was covered in a previous video, but this is what you do when you have resistors in parallel. So we have 1 over REQ, which is equal to 1 over 2 ohms plus 1 over 3 ohms. Find the common denominator, so we'll have 3 over 6 ohms. And that's because you cross multiply and get... I'm not going to go over that there. Okay, so we have 2 over 6 ohms, which is equal to 1 over REQ. And this is equal to 5 over 6 ohms. Flip, so we get REQ, or get the inverse of it, and we get 6/5 ohms for the REQ. So we take the 6/5 ohms for the REQ, ohms, multiply it by the 5 amps, which will give us, these two 5s cancel, 6 volts. Pretty simple, not a very difficult example. In the next example, example 2, we have 9-volt battery, a current going out, which we measured. We have R2 right there, but we do not have R1 right here. So what we're going to do is we're going to set it up using Ohm's law. So 9 volts is equal to 3 amps times REQ. Now we know what REQ has to be because we just take 9 volts divided by 3 amps. And that'll equal 3 ohms. So REQ has to be 3 ohms. And we know that 1 over REQ is equal to 1 over R1 plus 1 over R2, using, that's what you have to do in series. So we can do 1 over 3 ohms is equal to 1 over R1 plus, we know R2 right here, so we have 1 over 6 ohms. We then minus it over, so we have 1 over 3 ohms minus 1 over 6 ohms, which is equal to 1 over R1. Get the common denominator, so we have 2 over 6 ohms minus 1 over 6 ohms is equal to 1 over R1. So we have 1 over 6 ohms, which is equal to 1 over R1. Pretty simple, basic algebra, flip them, 6 ohms is equal to R1. So R1 is equal to 6 ohms. And yeah, that's it. It's pretty simple. I'm going to make another video over when they're in parallel and series. It sometimes gets more difficult when you're trying to take the potential over a resistor. But for example, in the case that I'm showing right here, I'll use pink so you can easily see it right here. The change of potential is V1 minus V2, which is right here, because if you think about it, the electrons going through the circuit at this point right here is the same as this point right here because they're all connected. And then after the resistor, they burn some energy, so they'll have a different potential down here. Now that'll be the same as right here and right here. So in order to get that change, you take the current, and that's how you actually calculate like I1. Real quick, I'm going to go through an example on how to calculate I1. I'm just going to wipe out this. So in the example that we have right here, we had I is equal to 5 amps, and R1 equal to 2 ohms. So we're going to calculate what I1 is equal to. So we know that the change of potential, there has one potential up here and one potential down here, and they're the same in all places because the battery, they're all connected together. They're all connected by the same wire, and the battery's connected at the same level of the resistor. Probably didn't describe that too well. We know that the V has to be equal to 6 volts. So V is equal to 6 volts. I is equal to 5 amps. And R1 is equal to 2 ohms. So if we take the potential across this, so change in V, divide it by R1, since we're only calculating the current through this portion right here to get I1, we should get I1. So that'll give us 6 volts divided by 2 ohms, and that'll equal 3 amps. To get I2, we could just take I minus I1, and that will equal 5 amps minus 3 amps is equal to 2 amps. Double check that using the change in V, and we had that equal to 3 ohms. So we have 6 volts divided by 3 ohms, and that'll equal 2 amps too. Okay, so now we have I1 is equal to 3 amps. I2 is equal to 2 amps. And then if you add them together, you'll again get I, which is right here, which is what I showed on here. What I was just trying to show is that you could easily calculate the different currents going through each section using this equation right down here. The change of potential is really great. It helps solve these problems a lot easier, and I'm going to go further into that in another video, which I'm going to have resistors in parallel and series, and I hope that'll help you out a little bit. But basically, I just wanted to show this real quick, and hope it helps. Feel free to comment. I'll try to help you out even more if I can. Thank you for your time.